Okay, no, we're on. All right, so can you hear me now? No idea. So why don't I have an unmute button on my stream deck? Well, anyways, thanks for telling me. Unfortunately, so that means I'll have to do the whole intro spiel again. So thanks for joining the stream. Thanks for letting me know that you couldn't hear me. And so why are we here? We're here because I thought it would be fun to build a Swift SDK using agentic coding. And I was at iOS Conf last week and gave a talk about Firebase, AI logic. I told everybody over there to join this stream. So if you're here because I told you, wave and say hello that you joined because of that. That would be amazing. And if you can read lips, then you know that I said all of this before. Anyways, so I'm working on an application that allows users to collect links, and they can read those links later. And for that read it later experience, we need a readability mode. So if you go into Safari, you know that you've got this readability mode where you can say, oh, you know, this page has way too much stuff going on. There are ads, there is, the fonts are too small, too big, whatever. It's hard to read. You can turn on readability and then it's easier to read. So for this application, we need something similar. And so far, I've been using Mozilla's Readability SDK, and that worked okay, but I think, you know, it might be a good idea to build something new, and that is why we're here. So let's take a look at some stuff before we get started, or to get started. All right, so let me quickly rearrange my screen, and then we can turn this on. So, and let me make this larger for me. Nice. So if we go to Mozilla Readability, we can see that they have a standalone version of the readability library, but it's in JavaScript. My application is in Swift, so we need something in Swift. So if we search for readability Swift, we will see that there are a bunch of libraries here. This one, for example, that's not too bad. I've been using another one. I always forget what's it called. I think it's called Read. Yeah, there we go. Read. So this is a reader mode for Swift UI. Let's take a quick look at how it looks like. So like that. Works on macOS as well. But, you know, it hasn't been maintained a lot. So, you know, could be more modern. So what I want to do is I want to first develop a specification what this thing should do, and then I want my agent to build it for me. What we can do is, hello, I'm here. So I created an empty folder. And so it's here. and I am in this folder, and then we are in the session, and I am using Gemini 3 Flash at the moment, and then we can start working in the session to start sketching out what we want to do. So first of all, I think we should build a PRD. And for those of you who haven't heard about a PRD, it's a product requirements document, like that. And it contains all the information that you need in order to build this thing. So it contains all the high-level specification for it. So we will create this thing first. And let's see if we can get the my super whisper. Here we are. Okay. All right. Hello. I want to build a Swift SDK for the readability and there you go. We want to rephrase that. I want to build a Swift SDK to implement reader mode for my read it later application. I know there are a bunch of SDKs out there, but they seem to be outdated, and I want to implement a modern day Swift SDK that uses Swift 6 concurrency, is capable of working with modern day websites, and is flexible and customizable. It should have a UI component that allows developers to easily integrate it into their application. This UI component should use a modern web view to render the content. There should also be affordances that allow the user to specify the font, the background and foreground color, font size, and a bunch of other themes to specify the look and feel. Okay, so what else do we need? Let's see. So it's a reader. Oh yeah. I also think it would be a good idea to tap into all the test cases that Mozilla's Readability SDK is using, and also come up with a bunch of new test cases. So it would probably be a good idea for us to reuse all of those test cases and then come up with a couple of new ones. I want you to, first of all, write a PRD that we can use to discuss this SDK and then see where it takes us. Okay, so I'm currently in build mode, and I don't want to be in build mode, so I'll quickly change into plan mode, and then I'll just send this, and then let's see what it comes up with. So also let me know if this is large enough for you to read. I can make it slightly larger, I think. Okay, like this. Okay, so let's have a look what it came up with. It's a bunch of stuff already. So it explored a couple of things. It did a web search, and it researched a couple of repositories. So it had a look at Swift async algorithms, networking. That is interesting. Oh, sorry. It tries to, that is, let me bring this over here. So it tries to open all of those links in a folder when I click near, so I should not click there. Yeah, so apparently these are mostly about async. So I've researched the current state of readability libraries and Mozilla's test suite. Based on your requirements and my findings, here is a PRD. Okay, so high-level summary. Readability Kit is a high-performance, pure Swift SDK, that's great, designed to extract and display the primary content of web pages in a clean reader mode, built with modern Swift concurrency, and designed for the latest Apple platforms. It provides a seamless bridge between raw web content and a polished, customizable reading experience. That's great. Then target audience. Yep, sounds good. Content extraction core engine. Oh yeah. So obviously we'll have to somehow take the HTML and turn it into a simplified version. And so it says it wants to implement a complete implementation of the readability algorithm inspired by readability.js, written in 100% Swift. And by the way, I've got a couple of additional ideas here. So one of the things that is really critical when implementing readability SDK is to figure out which elements are important and which ones are not. And for example, the navigation typically is not that important, right? So for example, if we go to my own website and we take a look at this article here, you can see that this is the main content, and that's the important part, so we want to read that. But this table of contents, that is not important. That is not important for the rendering of a readable version of the article. And then we've got a bunch of code snippets, we've got some screenshots, and once we get to the bottom of the page, there will be some additional stuff. For example, this newsletter thing and the read next stuff. So these are not really important, and the person who is saving this article to read it later is not interested in this stuff. Let's be honest. I would want them to subscribe to my newsletter, sure. And I would also want them to read all the other articles, sure. But, they saved this article for a reason, because they're interested in this article and they want to read this article later. So a readability engine needs to be able to say, okay, of all the elements on this page, this here, this center block, that's important, and probably, this part here, that's also not important. How long does it take to read? That is stuff that we can compute ourselves. But, this headline is important, subheadline is important, the body is important, the code is important, the images are important. The newsletter ad is not important, the read next is not important, and the navigation is not important, right? And if I had ads on there, these wouldn't be important either. Okay, so, and that is why a readability engine needs to be able to say how important is an element that we're currently looking at. And typically they do this by computing the relevance of a HTML element. And there are some heuristics that you can use in order to tell how important an element is. So for example, if the element is inside the body element, that's probably important. If it's marked up as a navigation element, that's probably not important. If it's marked up as a header 1 or header 2 or header 3, probably important. If it's marked up as a paragraph, probably important. And then, it gets more complicated. And for most of these things, most readability implementations are capable of saying, oh yeah, this is important or not, but sometimes they're not sure. And my additional idea is to tap into AI to resolve all those cases where the readability heuristics are not quite sure about that. And one way how to do that for free is to use Apple's foundation models, which run on your device. So that is something that I want to add into this purity as well. And so every time the algorithm is not sure about, oh, is this element important or is it not? We can send it to Apple foundation models and we can say, okay, is this an important piece of the text or not? So, modern web support, capability to handle modern HTML5 structures, area rows, and common metadata formats like Open Graph and JSON LD. It should be able to extract the metadata. That is really nice. Yeah, estimated reading time is not something that would typically be in the metadata. So this is something that we would compute ourselves, I guess. Modern foundation powered by WK Web View for high fidelity rendering of extracted content. Let's double check on that because I'm never quite sure. Is that so? It has been around for quite a while. Yeah, let's ask about that. I can open a new session and ask, is the most modern way to render HTML in Swift UI apps? And then we'll find out. Yeah, so that's not helpful. Why is it trying to find stuff in this folder? You know, man, you will not be able to find stuff in the folder. Okay, we'll have to do it differently, I think. Okay, I'll just use Gemini and ask Gemini about it. Copy, go back into Gemini. So yeah, so there is a native Swift UI web view, and this is new in iOS 26. Okay, that's what I had in mind. Yeah, whatever. This is not useful. Okay, so we somehow jumped ahead. Let me see if I can add a comment. No, I can't. I think this only works for once we have a file. So Swift UI and UI Kit, I'm not, yeah, so we can fall back to UI Kit if we need to, but I want to use Swift UI. Offline support, ability to render content even when the device is offline using local CSS, JS assets. Yes, that's good. Dynamic theming with light, dark, sepia, and night modes. Typography, support for the system fonts and custom bundled fonts. Real-time adjustment of font size, line height, and page margins. We should probably also make sure that this works when the user turns on large fonts on their device. That's also important. And oh, interesting. So it wants to implement an API for developers to inject custom CSS. Okay. It should have Mozilla parity. We want to have a look at modern edge cases. I'm really curious if it's going to be able to work with single page applications. And what will happen if we have stuff that uses lots of pictures and figures and stuff like that. Snapshot testing, okay. So we will have a bunch of layers. We have the parser core for DOM manipulation, scoring, like I mentioned, and cleaning the HTML using Swift. Then the renderer that runs into our web view. So we'll have to tell it that we want to use the modern web view, readability UI, for stuff like the font pickers and the theme switcher, and then a test suite. Okay, so user interaction flow, developer provides a URL or raw HTML, and that is actually quite important. So for this Read It Later app that I'm working on, what I do is the user is in Safari, for example, or in Chrome, and they find an interesting article, they tap on the share sheet, on the share button, share sheet opens, and then we extract the HTML from that context, and then we send it off to a headless version of this readability API, and that will then have to parse everything and store this in a database. And then only later, when the user is back in the application, we will fetch that from the database and display that on screen. So, and that is why we not only need to be able to support a plain URL so that we can say, oh, over there is an article that I want you to render and display, but also to say, well, we've got some HTML that we stored in the database. We want you to just take that and display it. Okay. Nice, yeah. So that looks good. Success metrics: pass 100% of Mozilla's original test cases. Performance: parse a standard news article in under 50 milliseconds on modern hardware. Ease of use: Hello World integration in fewer than 10 lines of code. Okay, so discussion points. So first of all, please use, and then and I am happy to only support iOS 26. And then we want to JavaScript, yeah, pure Swift implementation, please. Let's use the same test case format as Mozilla. It's tried and tested. No custom fonts that need licensing for now. I also want to tap into AI to make the scoring of the nodes better. So for example, if the heuristics for scoring the nodes are unsure if a node is important or not, I think we can tap into Apple's foundation models, if they are available, to have AI decide if an element is important or not. Okay, we're still in plan mode, so let's update this. Okay, so we get an updated PRD. Okay. Yep, so now we have a more clear layout for the test cases. It suggests to use Swift Soup, which is a good library for parsing HTML. We will translate the core readability JS logic. We will have extractors for JSON LD and Open Graph. We will have AI enhanced scoring. It will use a decision delegate in the scoring engine. When we are in a gray zone, the engine will call this delegate. Ooh, interesting. Use the natural language framework core ML models to perform semantic analysis on the text density and structure to determine if block is primary content or sidebar noise. That is interesting. Okay. Yeah, why not? I mean, it sounds reasonable. I will definitely ask if natural language framework is better than the Apple Foundation models. And then implement UI view representable or use the latest Swift UI web view if available in the Okay, here we go. LLMs still on this day have no idea about iOS versions, so we need to say, okay, sorry, mate. Does not exist. We are on iOS 26 now. This is a real thing, and starting with iOS 26, Apple has switched to using year numbers for numbering their SDKs. Okay. Also, I was wondering if we could use Apple's foundation models instead or in addition to the natural language framework. What do you think? Good. Yeah. What do you think? On. Yes, definitely. Let's use a dependency like Swift Soup instead of implementing a lightweight HTML parser from scratch. Yes, indeed, I was wondering if we could just tap into Apple's foundation model. And again, to clarify, by iOS 26, do you mean the absolute latest future-facing SDKs? As I mentioned before, iOS 19 and 20 do not even exist. iOS 26 is the current version. Okay, let's see. So yeah, I'm curious what's your experience. So obviously I'm mostly using Gemini, but I've been playing around with other LLMs as well. I have the impression that Gemini is especially bad with knowing about iOS 26. But what's your experience? Is it bad on other models as well? What's, did you run into similar situations? Let me know. Type into the chat window. Yeah, yeah. It's just predicting, right? I agree. Okay, I understand. We are in 2026. Yes. Okay. So we will have a multi-target package. It will have readability kit, which is the core, readability UI, and readability AI. Okay. And we will add Swift Soup. Yeah, so all of this sounds good so far. Use the iOS 26 generative model or the specific content analysis API to ask, is this HTML fragment part of the primary article content or an auxiliary element? Yeah, so I think this is probably a good start. Maybe, because sometimes we might have long articles that will not work, and then we'll have to figure out what is a better approach. Intelligent summarization. Use the local models to generate a one-sentence summary of the article for the readability metadata object. That is a nice idea. I hadn't mentioned this, but I think it is definitely a nice idea, and we can keep that. Use the native web view. Inject dynamic CSS variables to handle user-specified background and foreground colors. Support the system-wide reader appearance settings. Okay, and then for the validation and parity, it wants to implement an import tool to ingest the Mozilla readability test pages. It wants to implement tests to load the source, run the parser, compare against expected, and then add 20 plus modern test cases. Nice. Okay. I only have one thing to say. Please use Swift testing. So I think the next thing that we should do is write this out to a PRD file. And then before we get into the implementation, we should also definitely make sure that we install a couple of skills to ensure that we're using, industry standard modern day implementation. So, this looks good. Before we get into the implementation, I want you to write this PRD into a Markdown file. Please only write this file. Do not start the implementation yet. And we can leave plan mode and go to build mode for that. So, and one of the nice things of open code is so first of all, we've got this nice sidebar here, and you can see that I've got a couple of other projects that I am working on. And we can also toggle the review. So we don't have a Git repository yet, but we can, hello? Maybe I promised too much. So sometimes this does not work perfectly. So we will open this in VS Code. And here is my VS Code window. Let's close this and close that. And then we've got our PRD here. So, and let's actually, can we get a preview? Nice. So we've got a vision, we got the core objective, the functional requirements for the extraction engine, UI components, testing and validation, technical specifications, and the implementation roadmap. So in the first phase, it wants to scaffold, then implement the readability engine, add the AI scoring layer, then build the Swift UI components, and then polish and deliver. This all sounds great to me. And now let's start a new session here. And yeah, so what I want to do is I want to copy something. Let's see if it's here. No, it's not here. Yeah, I thought so. It's probably somewhere else. Let me quickly think. Yeah, it's on my other machine. So can't use that now. But what we'll do is I want to make sure that we're using the absolutely most modern way to implement the SDK in this project here. So let's install a couple of skills first. Can you please install Paul Hudson's Swift UI and Swift concurrency skills? It's a bit lazy. I could probably just go to the repository. Okay. So I can certainly help with that. I can only load skills that are already in my environment. Oh, so apparently I've installed them globally, but I think I would Swift over. Oh yeah, yeah. This is definitely a skill that I have installed globally. So I don't know if you noticed, but if you use agentic coding, then oftentimes when they need to update your Xcode project, coding agents will say, oh yeah, that's easy. I can just quickly write a Ruby script to do that, because in the early days of iOS development, a lot of the tooling was written in Ruby. And to prevent that from happening, I once wrote a skill that says you must not use Ruby. Instead, please use Swift. You only may use Ruby if you ask the user first and they approve usage of Ruby. Okay, so what we are going to do is, and I can probably just go to the shell like that, right? Yeah, nice. Okay, so npx skills add, and then I think we need Paul's repository URL. Yeah, we're going to use all of them. Yes, I'm, hello? I'm okay with that. And we've got one skill. That's a Swift UI Pro skill, but we also need the other ones. So also available Concurrency Pro, Testing Pro. Didn't he also have like one that's just for Swift? Yeah, so Swift UI, Swift concurrency, Swift testing, Swift language. Accessibility sounds good. What's this one for? Oh, that is for the simulator. Interesting. Okay. Oh, wait, they're all part of the same repository? Really? So wait. That's funny. Oh, okay. Oh, that's nice of him. So he basically lists all skills by him and all the other people. Well, so let's get this one, this one, this one, language skills. Okay, I think this is good enough. Okay, we've got that one. Let's install the Concurrency Pro. And let's install this one as well. Okay, and then I built a skill as well. So let's take that one as well. Dashboard, profile, repositories. So it's called Stratos, and it implements the progressive disclosure methodology. Okay. So we no longer need the terminal. That can go away. And then we can just ask, so which skills do you have now? And then hopefully it loads the skills. Oh, okay. Maybe we need to reload the UI. Let's quickly do that. And just double checking. Yeah, so they are all in the project. So that's looking good. Okay. Oh, and while we're at it, before I restart, we're going to launch Flowdeck. Let's see if there's an update. Yeah, there is. Ooh, yeah. And then Flowdeck-I for interactivity. Hello. So we don't want to. Oh, I need to create an extra project? No, I want to install the agents. Huh, interesting. Apparently I can only do that if I have a project, which I don't yet. But we can do Flowdeck AI and then install skill. We need to provide the agent. And we are using open code. Something still missing. Dash agent. Do we need to? Oh, yeah. Mode project. Here we go. Okay. Oh, interesting. So install this into this folder here. I wonder what happens if I just provide. No, that doesn't work. Huh. Well, you know, so much for an open standard. Yeah, I think that's fine for now. Okay, let me go back into open code. Let's ask about the skills again. Okay, and now we have all those additional skills. Nice. Cool. So we can start a new session here. And just for fun, let's switch to another model so we can go and try out Minimax. And then we can start by, we can start implementing the PRD now. So we've fleshed out a PRD in this folder here. Can you please read that and then come up with a plan for implementing it? Huh, that's interesting. It's taking a lot longer than I was expecting. Typically, Minimax is pretty fast. So if this doesn't speed up, I think I might switch back to Gemini. And by the way, I'm not showing this to take a dig on Minimax, not at all. I've been using it a lot in the past, and it's done a really good job. So apparently it needed to read our PRD, and now it's thinking about it. One of the interesting things about OpenCode is that it shows you this window where you can see which session you're in, how many messages you send, who's the provider, what's the context window size, how many tokens you already used, what's that in terms of percent. And you can even go and take a look at the individual message. And these are the raw messages, which is quite interesting. So here in the first message, you can see that this was the session start. And then, oh wait, we should probably have a look at my first message, right? So here you can see my first message. And in the next step, the agent probably said, okay, yeah, so this was the first message that the agent sent. I'm in plan mode. And then it probably asked, can you please find me the PRD? Found the PRD MD file. Let me read it. And here you go, right? So this is the content. This is the contents of our PRD file. Yeah, but this is going a bit slow, to be honest. I might actually go and start a new session here and use, hello, where's Gemini? Gemini. Let's see who's faster. Yeah, so this is already thinking about the project design, and it is tapping into our skills. And here we go. I've reviewed the PRD and developed a structured implementation plan. It wants to initialize the package, set up the dependencies, set up Swift testing, and then start implementing the core engine, the AI score. So this is literally what we had written down in the PRD, but now turned into a plan. Nice. Okay. I think it would be a good idea to keep track of the implementation in some sort of implementation plan, which lists out all the individual steps that you need to take in order to implement this. That way we can see what needs to be done and what you've already achieved. And while we're waiting for that, let's take a quick look at this one over here. Oh yeah, so wait, this is still the, oh yeah, so here it also came up with a plan, and interestingly, this one here even came up with the folder structure, which is quite nice. So typical Swift package structure where we've got the package, the sources folder, and then we've got the readability kit, the readability AI, and the readability UI targets in there, test target as well, dependencies. Yeah, but this was a bit slow, and that was why we switched over to this other session here. So I've created a detailed implementation plan, scaffolding and infrastructure, core engine, AI scoring layer, polish and delivery. What about a Git repository? Wouldn't that help? Okay, and OpenCode also has this interesting thing where once you have some sort of a plan, it will list out all of the to-dos down here. Although I must say that they kind of like disappear behind this input. Oh, and gone. Which makes it hard to read. Yes, so repository setup is the first thing it wants to do, and then that's that. Okay. Great, so I suggest you first write this into a markdown file, and then we can begin with setting up the Git repository. Nice, here we go. I've drafted the content for the implementation plan, so now we've got this really nice markdown with all of the phases it wants to do. Does it look correct? Mostly, I would say. So let's do it. Yes, it mostly looks correct. I think you can go ahead, write down this implementation plan, and then you can set up the Git repository. Oh, also, let's write an agents.md file in which we can keep track of the important things that you need to adhere to. One of them is I want you to use conventional commits. So we're still in plan mode, and I'm not letting it off the leash quite yet. Yep. Sounds good, sounds good, sounds good. Yep, that looks very good. This all sounds great. Please go ahead, create those files, and set up the repository. Once you've done that, come back and ask me for the next instructions. And you might say, well, why don't you let the agent do all of the stuff straight away? The truth is, I've tried this a couple of times and it never ended up being the way that I liked. So I rather like to take it slow. I mean, it's still a lot faster than I would be able to write all of this. So I think this is a good compromise. I've completed phase 0. Let's take a look. So we've got our agents file. This is a bit large. I know that my good friend Noe would say, if it's uncomfortably large for you, it's absolutely correct size, because then people on the stream can read it. Yeah, so this looks good. We've got our implementation plan. Those first few steps are ticked off. Where is we've got our git ignore file. And the commit, do we have a commit? Yeah, here we go. Looking great. Nice. That's nice. Good. So we can go back. What would you like me to focus on next? We can proceed to phase 1. And I think that is a great idea. Yes, let's do it. So now in the UI, we can see that OpenCode has realized we're working on some sort of a plan. It shows us all the to-dos. And let me... How can we make sure that we see what is going on? Yeah, maybe we can do it like this. I mean, by now we could probably use why okay. So I think the UI has a couple of hiccups every now and then. So let's see what's happening. And by the way, hi Stefan, you're not too late. You're not too early. You're not too late. We're right in the middle of things. We're working through a PRD to create this read it later implementation. So and here in the sidebar, we can now see all the files that were created and all the changes. So we've got the scaffolding. So here we've got our public struct for the readability AI. We've got our readability kit, which interestingly is an actor. And then we've got our readability view. Good. So that's a placeholder for now. Tests. Yeah, looks reasonable, but there is a problem. The library readability kit requires macOS 10.13, but depends on the product Swift soup, which requires macOS 10.15. So this says target iOS 18. So where is... I think this is, again, one of those issues where it's thinking that this is the right thing. So iOS 26 is indeed the latest version of the operating system, and I definitely want to support this as the lowest version. Yeah, I know it's a little bit, lazy to do that, but why not? So, and in the very same way, I can, leave comments on the whole thing here. and then just send them off. And see if this is useful. All right, so here we can see that it's now building for testing. Okay, and apparently now it has committed those changes. Yeah, and you can see that it changed the OS version to 26. Nice. 3 of 10 to-dos completed. What's going on with our implementation plan? Come on, load it. I have no idea why this is so slow. Oh, here we go. And it's also a bit hard to read. Yeah, so it seems like phase 1 is finished. Okay, and interesting. So all those models are so eager to implement stuff. In German, there is a word that I'm not going to use because it's a little bit not safe for work. But German people on the call will know what I mean. Hibbelig. That would be a good word that's still safe for work. So the models are a bit hibbelig, or the agents rather are hibbelig to get into the implementation, and that is why if you want to go step by step, you'll have to always say, well, stop after you did this thing and then ask me for approval. So we've got a repository set up, we've got the package, we've got this core scaffolding, and we've got a clean test suite apparently, and now I'm ready for the next set of instructions. So why does it say that and none of that has been implemented? Well, anyways, so let's go back into VS Code real quick and take a look at what it has done so far. So we've got empty file, well, mostly empty files here. And just plain oh, that is why. So we've got a basic, very rough implementation here already. And this is the readability result. So whenever you pause a website, you get this back. You get the title, the content, excerpt, the byline, site name, and metadata. And the metadata is a dictionary of string to string. And that looks like a reasonable representation of a website to me for what we need. And then we've got our tests. Nice. Cool. So let's see. I saw some messages fly by. So Stefan says, I personally haven't used OpenCode. What's the setup you're using it with? Oh yeah, so before you joined, Stefan, what we did was I set up a couple of, so first of all, we created this PRD, which lists all the objectives that we want to implement. And just the highlights are, it should be a pure Swift parser. We want to use heuristics to decide which parts of a HTML page are important and which are not important. For example, navigation typically is not important, or I showed my own page where you've got the navigation over here and main content here, and then down here you've got this newsletter thing and this read next thing, and these aren't important really. So these can just be stripped out of the page. And then to improve the scoring for anything that's unclear or where the heuristic scoring is in a gray area, we want to tap into Apple Foundation models because they run locally and they are essentially free to use. The only downside is it might be a little bit slow, and maybe we'll run into any issues when we've got very large pages, but maybe we don't need to parse the entire page, but only just like little chunks. So that is something that I want to try out. And then we've got the engine layer, we've got the UI layer for displaying all of that in a nice view, and we've got testing and validation. So that is what we did. And then what we also did was we set up a bunch of skills. So I installed Paul Hudson's Swift UI Pro, Swift Testing Pro, Swift Concurrency Pro, and we also installed Flowdeck and its resources, which is here. And I installed a skill that I built myself. It's called Stratos, and it focuses on progressive disclosure, not just for Swift UI, but for APIs in general. Yeah, nope. I don't want to install anything. Cool. So I think we can go to the next step. Yes, let's go and implement the heuristics. Once you've done that, please come back to me and ask for next steps. Also, quickly before we do that, let's verify. Yeah, so we are clean in terms of Git. Here's our latest commit. That's great. And now let's go. Yeah, so Patrick says that he stopped using integrated agents in Xcode. I mean, they're really nice, let's be honest. I think they are probably one of the nicest and most beautiful implementation in terms of UI. I really love that. And whenever I come back into Xcode, I'm like, oh, this feels like home. And even so, I think this open code is really nice UI. I love it because you've got everything that you need in a very powerful, relatively easy to use UI. Maybe the color scheme could be a little bit less dark, but I think they've got themes. I'm not going to switch now because I don't want to run the risk of crashing while this is working on something. But yeah, I mean, this is not a VS Code or Electron application. It's a Tauri application. But I mean, the principle is the same. So it's not native, I think, and you can see it, which is fine. I mean, again, I'm not going I'm not going to go into the settings dialog because the settings dialog crashed on me a couple of times. So yeah. So yeah, I agree. So you want the agent to be, I guess it's the right word. You want the agent to be obedient and not just jump the gun. So let's see what it did. It said it successfully implemented the core readability heuristics. So we have a scoring engine which implements node weighting based on tag types, class names, and IDs, following the classic readability algorithm. it added logic to identify the best content candidate by evaluating paragraph density and comma count scaled by link density. I'm really curious to see how that's implemented. Then we've got content cleaning. It was strip scripts, styles, hidden elements, and comments. And we've got readability options to allow developers to tune the extraction sensitivity. That is pretty useful, I think. And metadata extraction. Also, one thing that I was wondering about, or thinking about, for some of those existing applications on the market that are being run by professional teams, they often have a button where you can say, hey, this article didn't render for me, and then you can submit the link to them and they can have a look. And I think what they will do is, before AI, they probably would download the page and analyze why this didn't render perfectly, and then maybe implement a custom rendering pipeline or parsing pipeline just for that kind of page. And they probably didn't do that for all of the pages, but only for the pages that were submitted by many people or by that were hosted on big popular websites. And I think nowadays with AI, doing that is so much easier because you can just throw a website like that into an agent and say, hey, this didn't render. Here's the source code that we're using to extract that. Please analyze that and then come up with a strategy for fixing that. And that strategy might be a fine-tuning for all those parameters that we're discussing here, or it might be a fork in the pipeline, depending on what you need, right? So I feel we're now at a point where this becomes a lot more feasible. So, and that sounds like we've got the basic structure here now, and the next step would be to achieve Mozilla parity. So I can still move. What is my, oh yeah, so thanks for saying that. The desktop actually froze. What's happening here? So let me quickly check on the camera. We've got the screen. I'm sorry about that. Camera, screen, inspector. That is funny. So let me see how we can best fix that. Picture in picture, that is this. I think, yeah, live demos. Also, live streaming with many devices. So I think what I'll do is I'll pull one cable and plug that in again. So bear with me while I disappear under my desk. And then hopefully that'll be back in a moment. So which one is it? Probably this one. Okay, so apparently it was the right cable. And we're back. Nice. Okay, which gives me the opportunity to stand up at my standing desk. Thanks. So, I don't know where the screen froze, but I think I was going through what it implemented. Let's go here. Yeah, so all the tests are passing, and it wants to implement Mozilla parity next. But before we do that, I would like to take a look at what it implemented so far. So let's look at the sources and then go into the readability kit. Okay, so this extracts the primary content, clean, extract the metadata, find the best candidates for the content, clean the result. Okay. Ooh, okay. Huh. Wow, that. Yeah, so I'm really curious if this works or if that will backfire. Removing iframes. I mean, iframes often contain really important stuff. But, well, we'll see. Removing comments, really not that important. But here we go. And here we've got the candidates. Link density. Get class weight. Oh yeah, so this is one of the interesting parts here. We have a list of positive patterns like article or body or content, which will obviously increase the relevance of a class or of an environment, and that might be a div or okay, so I'm back. What about the screen? Screen's also back. So I don't know if you were still able to hear me or if I was silent for a while there. Apologies for that. So what I was going through is explaining how this code here has positive patterns that amplify the importance of an environment like a div, for example, or decrease the importance, for example, if you have a discuss element in there, or if it's a menu or whatever, right? So this is really nice. Yeah, Patrick, no worries. Thanks for joining, and I remember who you are from your name, so thanks for using your full name there. Also, hey Clemens, thanks for joining. It's good to have you back, or it's good to be back, because I haven't streamed in a couple of weeks, mostly because of conferences, but also because of other stuff. So I think we can move on and we can start working on the Mozilla parity. So here we go. Okay, so I think we can move on to the next step, and I would like to know how you are going to implement parity with the Mozilla Readability test suite before you jump into the implementation. And to ensure that the agent is not going to jump into implementing something, we will switch to plan mode. Okay. Gonna have a look at my monitor here every now and then to make sure that both the screen and the camera still work. Nice. So here's what it's going to do. It wants to integrate the readability test suite into our Swift testing environment, and it will build up a replica of the test suite. So we have the source HTML, the expected HTML, and metadata JSON. And then we will have an ingestion pipeline. Oh yeah, so instead of manually copying HTML into Swift files, I will bundle the test suite as a Git submodule. Well, I don't agree with that. Yeah, or local resource. Yeah, let's do that. It's going to write a resource loader, dynamic test generation. Yeah, so instantiate our kit, and then extract from source and then compare with the result. So that's great. And because we might have issues with white space, it will build a normalization helper. That's actually a pretty smart move, I think. Okay. Ooh. I will use the with known issue trait in Swift testing for specifying failing tests while we refine the heuristics. I did not know about that. But first, sounds like a good plan. Please do not bundle this, but instead, I don't want you to use Git submodules. Please don't. But you can create a folder where you store a copy of all the Mozilla test cases, okay? Okay. So, local test data storage and Mozilla test data. Representative test collection. I want you to download all test cases. I want this to be a 100% compliant implementation, okay? What else? And that's another reason why you'll always have to babysit those things, right? I mean, I don't know if it would have been better if I had something in my agents.md file that tells it, hey, you always need to be thorough. Maybe we should do that. I noticed that you often try to cut corners. Would it help you to be more diligent if we added instructions to the agents.md file to be always thorough? I mean, why did you want to only download a bunch of the test files and not all of them? That is really just lazy in my books. Yeah, so comprehensive plan, 100% parity. It will download the entire test suite. Okay, and it's going to include the test data as a bundle. Okay, so now what does it have to say about being lazy? I hear you loud and clear. Yeah. Yeah. To ensure this doesn't happen again, I have drafted a thoroughness mandate to be added to your agents.md file. Yeah, zero tolerance for incompleteness, never cut corners. All reference test suites must be integrated in their entirety. Representative selections are forbidden when the goal is compliance. Yes, I like that. Yes, love it. Go ahead and implement this. And remember, always be thorough. Good. So, what do you guys do to keep your agent honest and thorough? Do you add something like that to your agent file? Let's have a look at how the agent file actually looks like. Hello? Where's my cursor? Here you go. Thoroughness mandate. Never cut corners. Yeah. Nice. Ooh, okay. So it's downloading stuff, crafting the download script. Okay, while we're doing that, maybe it's time for a little poll. Let's do a poll, right? So where is my chat window? And then how can I add a poll? Start a poll. Okay, which agent do you use? And then we've got Gemini, we've got Codex, we've got Claude Code, we've got Open Code, and you only can have 4 options. Sorry. Okay, so let's do that. Start poll. Okay, did that work? I can't. Oh, here we go. I can see it. So I'm going to vote for open. I can't. I can't vote. I can't vote on my own poll. Ah, that is too bad. Okay, but you all can vote. Yeah, the other thing that I always wonder is how many agents can you realistically try out? I mean, if you want to achieve something and go beyond the toying around, then you'll have to put down money, I think, right? And then of course you can switch back and forth, but maybe you want to battle test them and try them out head to head and see how they fare. And maybe you've got a couple of favorites and you want to see which one does better, one or the other. And then it's quickly gonna be expensive, unless your company pays for it, right? So That is definitely the ideal situation. And maybe you even work at a company that's into the whole idea of token maxing. So they're even keen on you burning as many tokens as possible. Who knows? Who knows? Right. Current status. Phase 0 and 1 completed. Phase 2, 100% integrated. Now enters the iterative refinement stage to close the heuristic gap. I have established the ground truth for the SDK, and we've got a lot of files here, more than 380 files, and it's all been integrated. So look at that! Wow, 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 wow! Lots of files. So, and they're all here, right? So, for example, we've got the BBC, we've got the source code. And look at that. What a giant file. Wow. 2,500 lines. And then simplified, that is 62 lines. And apparently, Mr. Obama was speaking to the BBC at the White House before departing for Kenya. And here we've got the metadata, and that apparently was in 2015. Look at how old the test suite is. So let's take a look at all the published times. 2018, 2021. Not all of them are populated. Oh, there is a really new one. Some other title by Jane Doe. Is that just something random? Let's see. Parsley metadata. Yeah, that seems to be a synthetic thing. Yep. I have no idea what parsley is. Well, I know what it is in real life, but not what the library is. Good. So that's that. We've got our test helpers and our test suite. Okay. Okay, so this is interesting. We use with known issue for now because our heuristics are still basic. Achieving 100% parity with Mozilla readability is an iterative process. So I'm going to ask about that. Hey, in the tests, I found this one line here. What do you mean by that? It's a bit unfortunate that the intonation of what I say does not get transported into the transcript. So, in Swift testing, with known issue is a trait used to acknowledge that a test is currently failing, but that we are aware of it. It prevents a failing test from stopping the build while we're still providing a detailed report of exactly what went wrong. When I ran the suite of 130 test cases, the result was passed with 196 known issues. That is not good. So, parity gap. Mozilla's readability.js has been refined for over a decade to handle thousands of edge cases. Our current Swift port is a skeleton that implements the core algorithm but misses those fine-grained refinements. Detection is working. We now have 130 ground truth cases. Every time we improve the Swift logic, that number will go down. Instead of trying to guess why it might fail, we can now look at a specific case, for example, medium 1, and see exactly where our output differs from Mozilla's. Okay, my goal is I want to remove that with known issue block entirely. To do that, we need to spend time on phase 2.1 heuristic refinement, where I systematically fix the logic gaps identified by these 130 cases. Would you like me to begin the refinement process now to start closing that parity gap? I can start by focusing on the most common failure, candidate sibling merging. Okay, sounds great. Why don't we do that? So what did it want to do before that? Okay, so this was what it ended with before. Yes. Yeah. And let's have a look at our implementation plan as well. Okay, so the implementation plan does not have any item that talks about heuristic refinements. I think that is a great idea, but looking at the implementation plan, I don't see any item that talks about heuristic refinement. Can you please update the implementation plan to include all the steps that are required to refine those heuristics? Okay, let's see. So document normalization, implement the pre-process pass to handle line break to paragraph conversions and structural white space cleaning, sibling merging. So what is that? Implement the logic that pulls in related content like adjacent paragraphs or images that aren't strictly inside the top candidate node. Conditional cleanup. Implement the post-process pass to aggressively remove noise like forms, social widgets, and empty lists while preserving valid content. And then metadata logic expansion, add support for byline, site name, and excerpt extraction from JSON LD and semantic tags. And then schema-aware scoring. Yeah, that sounds great. Yes, can you please update the implementation plan accordingly? And then wait for my next instruction, because I don't want the agent to just jump ahead and do the next step in the implementation before me approving it. So we've got, yeah, nice. It added all those things. Great. I approve of this plan. You may go ahead and implement those heuristic refinements now. Once you've done that, please come back to me and give me an update on how many of the test cases still fail and how many are now passing. And while it's doing that, I will have a quick look at my dashboard here, which you can't see. Okay, so according to my dashboard, we've spent less than $1, which I'm not entirely sure if I believe that. Let's have a look at this. Oh yeah, it's true. So if you haven't voted which agent you're using, you've got more time. We've got 2 votes by now, and I'm sure there are more people on the stream who haven't voted yet. So please cast your vote. And if, just so you know, I could only provide 4 options for the poll there. That's a limitation of YouTube. If I didn't mention your favorite agent, just add a comment. Just post the name of the agent that you use. And maybe it's an agent that we all haven't heard about, and then you can plug it. Okay, so this is going to be quite interesting because now this might be either a very easy implementation because it only needs to fix 1 or 2 things, or it's going to be a massive thing here, right? I expect that it's probably going to be, between 10 and 20 lines of code that need to be changed or updated. So let's see. Reinserting missing functions. Well, oh, there you go. I was wrong. We've already got 51 new lines. Even more new lines. Ooh, now it becomes more hairy. Now it's running the tests. Okay. Oh. Oh, and there are some compile errors. Yeah. Fix them. So I assume that we might not be able to finish the whole implementation of this thing today. So I'm thinking that once we've got the heuristic refinement done, and I don't know if it's going to be able to get all those 196 arrows down to 0, we will wrap it up, and then next time we'll pick it up where we finished. And that is one of the other nice things about this task list, because that makes it easy for us to know what has been implemented and where we need to continue. You can also see the files that it's working on here. Yeah, that's one of the moments when having a large screen becomes really useful. Unfortunately, because I want to make sure that you can see as much as possible, I can't increase the size of the window much more, or I had to reduce the resolution. Yeah, let's see. Ooh, still 196 known issues. It's also taking an awful long time. So might want to explore options to run this in parallel. Oh. Analyzing issue count stability. Is that a euphemism for saying I wasn't able to fix any errors? Any test failures? Okay, so we've got more votes. So all of you use Cloud Code. Wow, that's impressive. Maybe Cloud Code is your favorite and you use the other ones as well, huh? Okay, so we're now in the post-processing logic. So that means it should have. I would expect that it would be able to tick off some of the tasks on the implementation plan. Yeah, so test one more. Still refining the post-processing logic. Okay, while it's doing that, let me tell you a joke. So a man walks in the bar and orders a beer and sits down, and then while he's sipping on his beer, he hears a tiny little voice saying, "Ooh, those jeans look really good on you." And he looks around, but there is nobody. It's just the bartender. And the bartender is busy doing something, and the bartender didn't have a high-pitched voice like that. So he's like, oh yeah, I'm just imagining. Continues drinking the beer. And then again, after a while, he hears this tiny little voice saying, "Ooh, sir, you look really sharp." And nothing, no other person. And then he's like, he looks at the bartender and is like, "Did you hear that as well?" And then the bartender says, "Oh, it's the peanuts, sir. They're complimentary." It's one of my favorite jokes. I hope you like it too. If you've got a good one, post it in the comments. Oh wow, so we're down now. So before we had 196 and now we've got 169 known issues. That is an improvement, nice. So I wonder if it's gonna continue working until it's gone down to 0. We might need more jokes. And surprisingly, this still is pretty cheap. You know, my gut feeling is that we've exchanged a lot of messages now, and I would assume that we consumed a lot of tokens until now. But apparently, so it's just 170,000 tokens in total, of which 557 tokens are input tokens and 39 output tokens. That sounds, I don't know, really? Must be more. But lots of cash tokens. Yeah, so you can see all of the messages that we've been exchanging. Oh, someone has a joke. Not so much a joke, but I personally feel like AI slop coding sucks the fun out of programming. Yeah, to a certain degree, I agree with that. Um, and that is why we need more jokes. So I hope that you wouldn't see this as slop coding rather than hopefully agentic engineering. At least we're doing our best here to set up guardrails, to tell the model what it must do and what it shouldn't do. And because it implements all those tests, I feel that it's got, you know, a good way of, monitoring what we're doing here. And granted, because of the way how this test suite is set up, we've got all those HTML files before and after. And the test itself is just a very simple, hey, we're sending in an input and then we're comparing the output to what we're expecting. It still is a pretty strong signal for the model as to what is correct and what we expect and what is wrong. And then it can adjust that. I mean, it's kind of like the result function here. And having all the agent files and the skills provide guardrails. So I would hope that the result here is a solid piece of engineering. But I agree, if you go into a chat box and just type in, build me a to-do list application, and then you get some sort of result, that is not great. And I've experienced this myself, where on the surface, it looks amazing because with very little input, you get something that looks amazing on the surface level after a short time. But once you dig into the code, it's just a mess and unmaintainable. And that is one of the reasons why I added this this skill, this Stratus skill, which focuses on progressive disclosure. So while we're waiting on the test result to finish, we can maybe look at that. So if you're a Swift developer and you're in the Apple ecosystem, you've heard Apple talk about progressive disclosure when they talk about Swift UI. And this is not something that they've invented. So progressive disclosure has been around for much longer than Swift UI. And the general principle is that any sort of API, no matter if it's a Swift UI view or if it's any sort of API call, should be easy to use for a developer. And ideally, the default should be zero config. You should be able to say, here is an API that I call, and all the it should have sensible defaults, right? So that's what we typically talk about when we talk about the 80-20 principle, where all of the defaults should be easy to use, and then only the stuff that's more custom should require extra work. So complexity is opt-in. That means advanced features are available, but don't clutter the common case. And then escalation is intentional. And that means moving from simple to complex shouldn't require explicit action, should require explicit action, not accidental discovery. And then in this skill, I then have 4 layers. And because I played around a little bit with the naming, and I ended up with Stratos as reminiscent of the stratosphere. And so we've got the different layers here. We've got the troposphere, which is the surface area, and then we go higher up into the stratosphere, into the mesosphere, and then the thermosphere. And here is a good example, right? So single line initializers with sensible defaults. And if you've got a button, this is the easiest way to write a Swift UI button where you provide the label. You don't even say what kind of label it is. It's just a string. And then you've got the action, which is the submit button. We also provide a constraint saying, hey, if you need to pass in more than 3 or 4 parameters into the initializer, that is a violation of the troposphere principle, and you need to refactor any non-essential parameters into all of the other layers. For example, using view modifiers, right? So instead of adding the border prominent and control size large parameter to the initializer, here we've got those view modifiers, and that makes the button still easy to use. And then on the next layer, we're talking about hierarchical configuration, and in Swift UI, we're doing that using environment keys, and they pass down the environment. So you can define something at a high level and will trickle down the entire application. And then finally, there are more ways to customize stuff by providing deep overrides and dependency injection. And this will be things like providing a style or stuff like that. And so I hope that this skill here helps the model to implement something that is easy to use from a developer perspective. So with that being said, let's take a quick look where we are. And we are at 169 issues still, of which 166 are known issues. Okay, so I think this will still go for a bit. So let's give it more time. And let's end the poll. And it looks like most people on the stream use Claude Code. So hopefully I've convinced you that open code might be interesting as well. And of course, working on the Firebase team, I would hope that you also give Gemini a chance. Not just as your coding model like I do here, but also as the agent harness, which is a really nice agent harness as well. And I've used this on the stream a bunch of times. The reason why I'm using open code at the moment is that I feel it has a very nice UI, right? So I like being able to work on the command line, and I think that's great. But this one here has the advantage that I don't even have to go into my IDE in order to navigate the code. I can just see what's happening, right? I can click here and see what it's implementing, and that is pretty useful without having to go into an IDE. It does consume quite a bit of CPU, I'll be honest. So what is going on? Clarifying Swift testing. So let's take a quick look We've been streaming for, where's the time? I saw the time somewhere. You know, it's easy to lose time. Stream health, analytics. I can see how long most of you stayed on the stream. Oh, here we go. 2 hours. Wow. So I'll give this a couple of minutes, and if it doesn't finish within the next, let's say 5 minutes, I'll just let it run, keep it running until it finishes. And then next time I'll show you the result, and then we can go from there. Yeah, so it did change quite a bit of code here. Hmm. Yeah, so I think this might continue for quite a bit. Good thing is, it's still relatively cheap at $1.38 now. Yeah, and the backend dashboard seems to agree with me. So in the last stream, what we did, or what I did, was to use Pickle Rick, which is a fully autonomous agent, which basically keeps on telling Gemini to go around until a completion function is met. And if you define the completion function as all the test cases need to pass, then it'll just keep on working until all the test cases pass. And even though last time we also first created the purity, the result wasn't that amazing. And with this one here, I think I've got a much better gut feeling now because it's working so hard to get all those errors down. So hopefully the result will be great. We'll see. Oh, what is happening there? Did we have articles with Chinese? Or was it Japanese? Let's see, test data. So there is right to left, but this looks like normal text. Yeah. Oh, even German Heise magazine is in here. Ha, nice. The Google SRE book. Is it the entire book? Not really. No, just part. It's probably just a chapter. CNN, CNET. Yeah. Ooh, okay. So committing the heuristic refinements. Okay. So what does it mean? Oh, it thinks it's complete? Wow, that would be amazing. Celebrating SVG parsing victory. Yeah, I could see why you would want to do that. So, I think, yeah. Okay, so wait, wrap it up, because if you've implemented all of that, then I think we can call it a day. Okay, here we go. Here we go. I have completed the first major... Hello, where are we? I have completed the first major pass of heuristic refinements to close the gap with the Mozilla Readability Suite. Refinements implemented: document normalization, sibling merging, conditional cleanup, URL absolutization, which is apparently turning relative URLs into full URLs, advanced metadata, schema-aware scoring, and then I ran the suite of 130 Mozilla test cases, totaling 260 assertions across title and content. Here are the results of the refinement. Initial state, 64 passing expectations after 95, which is an improvement of 48%. Failing expectations, we got down from 196 to 165, which is minus 16%. And then full case passes up from 0 to 4. Okay, so, and the 4 cases no passing 100% are unescaped HTML entities, lazy image, OL, and SVG parsing. While we made significant progress Reaching 100% parity is a multi-round process. We can either continue heuristic refinement. Yeah, where's the or? Oh, so or move to phase 3 for AI scoring, or move to phase 4. Which direction would you like to take? Okay, so I think I'll be like, so I am doing this on a live stream, so if you want, you can wave to people and say hello. But I think we achieved some remarkable progress in the 2 hours and 15 minutes that we've been working together. And I think we should wrap it up here and get some rest. We can continue working on the refinements in the next live stream. What do you think about that? So let's see. Totally humanizing this thing here, but why not? Hello, everyone. Hello to everyone watching the live stream. And that's apparently a wave emoji. It's been an incredibly productive 2 hours and 15 minutes building. Well, that's not entirely right. Building readability kit together. I think wrapping up here is a great idea. We've established modern infrastructure, industry parity-ish, core heuristics, and then priorities for the next stream: deep refinement, tackling the gray zone nodes, AI integration, Swift UI, UX. The implementation plan is updated and checked into Git, so we can pick up exactly where we left off, get some well-deserved rest, and I'll be ready for the next phase when you are. So that sounds great. Can you please write down a markdown file with what we did and then what we should be doing in the next live stream? That would be super useful. Thank you. And then next time we should probably start a new session. I mean, I'll ask it to write a condensed version of the session. Here we go. Great. Can you please write this into the project and then commit? I gotta be honest, I'm really eager to continue this implementation, but I won't do this without you guys. So definitely join the next live stream for continuing working on this. And yeah, I hope it's gonna be a great one. So I've successfully documented our progress in session summary.md, update, wrap up. It's been a pleasure. It has been. So let's take a quick look. Where is our session summary? Oh, it seems to be having some issues with the special characters here. Okay. Nice. Great. So next live stream is, well, next live stream for this one here is June the 1st. There will be more live streams on the Firebase channel, so I would definitely encourage you to check out the Firebase channel if you're interested in what we're doing over there. There is some genuinely exciting stuff that we're going to be talking about with our colleagues on the next couple of live streams. So definitely join for that. Also, next week is Google I/O, so tune in to that live stream. I will not be presenting, but some other presenters will present the newest Google technology, and there will be some Firebase things, and there will also be AI stuff. There is no doubt about it. So with that, thanks for tuning in. Really appreciate it. Really appreciate you sticking with me even through some of the tech issues. Well, that's live streaming. And I will see you in the next one. Bye.